Good morning, friends. I am Dr. Yagya Dutta Dwivedhi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. As a part of my flight mechanics course, I am in the problem solving sessions where I will be taking some numericals. These numericals are related to the gate and some other books. Today I am going to take the VN diagram and the load factor. In this, I am going to take the first, these are the topics for the day. The first is the determine load factor, compare the velocities, determine horizontal distance and the rate of climb, plot VN diagram. So, numerical 1, consider an aerobatic aircraft with a mass of 1500 kg, diving with a velocity of 100 knot. Number A, if the aircraft pulls out of the dive with a radius of 150 meter, determine the load factor. So, if you see your aircraft is here and it is the radius R and it is pulling out. So, we have to find out the load factor N. If the maximum allowable load factor is 6. So, if N max is equal to 6, determine the minimum radius. So, minimum R minimum, what we have to find out. So, this is the problem which we are going to handle. So, now if you see about the solution, so here if you see given the aerobatic aircraft with a mass M is equal to 1500 kg and the velocity of this aircraft is 100 knot. So, it is a pull out of the dive. So, if I draw here, so aircraft is diving from here and you are at the last here and aircraft is here. So, we have to find out the radius is 150 meter from here. This is the R. So, we have to find out the load factor N. So, we know that I will just change the color. So, load factor we have to find out. Load factor. This load factor N we know that V square by RG plus 1. V is equal to 100 into 0.5144 whole square divided by 150 is a radius and G is 9.81 plus 1. So, you will get N is equal to 2.8. So, this is the answer for the first problem. Now, we will see the problem number B. Here it is asking something. So, this we will see that. Next is, if the maximum load factor N max is given 6, determine the minimum radius. So, minimum radius R minimum we have to find out, and we know that the R minimum equation is R minimum is V square by G N max minus 1. So, we have given 100 into 0.5144 whole square divided by 9.81. N is given as 6 minus 1. So, you will get the minimum radius is 54 meter. So, this is the R minimum. Minimum radius is 54 meter. So, this is the answer for the B. So, this we have done the one problem. Now, we will see the second problem here. That so, numerical number 2, determine the orbital velocity of a spacecraft at an altitude of 200 km from the Earth. If the weightlessness is desired, assume the gravity is 9.8 meter per second square at the height of 200 km and the Earth radius is 6371 km. Then compare this velocity with the speed of sound at the sea level, that is 340 meter per second. So here the things are given here. Given here R is given, R, so it is 100 plus 1000 plus 6371. This is the meter of the radius of the earth, because it is 200 kilometer, so 200 into plus 1000 plus the radius of the earth. So we know that we have to find out the velocity. So we know that this G is equal to V square by R. V is equal to under root G into R. Under root G is 9.81 and R is 200,000 plus 63171,000. So you will get velocity is equal to 8025 meter per second, or 8.025 kilometer per second, or 2888.9 kilometers per hour. So now we have to see that if you compare with the speed of the sound, so it is M is here, Mach number is 8025 divided by 340. So this will be 23.6 times higher than the speed of sound. So 23.6 times it is higher than the speed of the sound. So we will now, we have solved this problem. Now we will go for the next numerical number 3, and this we will see here that an Airbus 300 is employed in a zero gravity flight. The flight is started at 8000 meter with a velocity of 440 knot and last about 20 seconds. Determine horizontal distance traveled, height lost, vertical velocity, average descent angle, and total velocity at the end of 20 seconds. Ignore the drag force in the Z direction. So here zero velocity gravity is there. The flight started at 8000 meters. So you have here H is equal to 8000 meters, and we have the velocity here 440 knots. 440 knot, and so we have to find out horizontal distance x. So we know that first the horizontal distance x is equal to v naught into time t. V naught is given 226.3 and time is 20. So you will get here 4527 meter or 4.5253 kilometer. So this is the horizontal distance. This is the first answer. Now we will go for the B, second problem B, or the second one. Height, HEI, height lost. This height lost delta H is equal to half GT square. So half G is 9.81, T is equal to 20 square. So you will get this as a 1961 meter or 1.96 kilometer. So this is the delta H. So this is the second answer. Now we will go for the C. Vertical velocity vertical velocity, that is Vz, is equal to G into X divided by V naught. G is equal to 9.81. X we have find out from here. It is 4527 divided by velocity is 226.3. You will get this answer as 196.1 meter per second or 381.2 knot. So this is the third one, answer for the third case. Now we will discuss the fourth issue, that is the D problem, and it is average descent angle. Average descent angle, and this is, we know that it is a gamma is equal to tan inverse H by X. So if you see here, okay, so this is the gamma, your aircraft is here, this is the H, this is the X, so this is also gamma, so this is the tan inverse H by X, and we have find out the H also. H we have got 1961 and X we got 4527, so you will get this as a 23.4 degree. So this is the descent angle for 23 point. So this gamma is 23.4 degree. Now next is a total velocity. So I will here total velocity V is equal to under root Vx square plus Vz square under root 226.3 square plus 196.1 square. So we will get here 299.5 meter per second or 1070 kilometers per hour. So this is the answer for the last problem. So now we will go for the next problem. This is the problem number. So here we will, next problem we will go for the problem number 4. So here we will see that drawing the Venn diagram, plot the flight envelope Venn diagram of the following GA acrobatic aircraft, then determine the maximum load factor. M is equal to 2300 kg, S is equal to 19.33 meter square, CL maximum is equal to 2 and minus CL maximum is equal to minus 1.2, aspect ratio is equal to 7, CL alpha is equal to A is equal to 6.3131 per radian, VC is equal to 310 knot. So this we have to see it that. So here we will do is that, so here given plus n max is equal to plus 6 minus n max is equal to minus 3, Vd is equal to 1.55 Vc, so 1.55 into 310, so 480.5 knot. Okay, so from here we can start that for the coordinated turn F and G, that is 64805 and at minus 3 into 4805 to determine the coordinated point ABJK, we need to find out the CL max. So first we have to find out the Vs is equal to under root 2 mg by rho s CL max. So 2 into 2300 into 9.81 divided by 1.225 19.33 into 2, so you will get here 30.87 meter per second or 60 knot in the equivalent airspeed. So thus the coordinated turn of A is 1,60. The top stall curve of the load factor as a function of airspeed. So load factor N is equal to rho V square SCL max divided by 2W. So 1.225 velocity we have just now find out. So putting this value as 30.87 into 9.33 into 2 divided by 2 into 2300 into 9.81, we will get this N is equal to 0.10010 V square. Okay, so here is the V square. So in this way we can, for the point B, load factor given is 6. So this 6 is equal to 0.10010 V square. So V is equal to 75.6 meter per second. So now we will see the lower level. So these all things are here. So we got this value, now this value. So now this for the coordinated of the point B is 6147. With the same technique we can get this lower level and we will get here 77.5. So if you see this VN diagram for this, it is a positive side, it is a negative side. We got this point and this point, and all this A, B, C, D, E, F, G we have just find out, and we have, so the coordinates of the point K is -1, 77.5. The lower stall curve or the load factor as a function of the airspeed in meter per second is, here we have find out this. From here we can get the speed at a -3. So -3 is equal to this V square. So we got the V is equal to 69 meter per second, 134.2 knots indicated airspeed. Okay, so these all parameters. So we got all the point from O is 00, A is equal to 160, B is equal to 6 into 147, F is equal to 6 comma 480.5, G is equal to -3 480.5, J is equal to -3 134.2, K is equal to this. By using this data we can plot this VN diagram. So this is the assignment problem which we can do in your homework. So I have given here very good problems that you can solve. The next lecture I will be discussing about the climb thrust effect of the wind, determine true airspeed in the equivalent airspeed, determine stall speed, and so on. These are the references that Aircraft Performance and Design International Edition, McGraw-Hill's first edition, 1999. Issued by ME Aircraft Performance Theory and Practice, AIA Education Series. Any questions you can ask to ydwivedi@gmail.com. Please do like and subscribe my channel, and so thank you very much for joining.
Like, share and subscribe. Hit the bell icon for more updates.